Slide 1. Welcome to Networking and Health Information Exchange, Supporting Standards for EHR Application. This is Lecture A. This component, Networking and Health Information Exchange, addresses what is required to accomplish networking across and among disparate organizations who have heterogeneous systems. Unit 7 covers Supporting Standards for EHR Application and consists of 4 lectures. Over these 4 lectures, we will talk about the additional standards that are available to support interoperability across different applications that relate to or are interactive with the electronic health record. Lecture A presents a clinical decision support standard, the Arden Syntax. Slide 2. The objectives for this unit, Supporting Standards for EHR Application, are to understand the Clinical Decision Support Standard Arden Syntax, understand standards for clinical guidelines, understand Object-Oriented Expression Language for Clinical Decision Support, JELO, understand the Clinical Decision Support Standard Info button, understand disease management, and understand other clinical decision support applications. Slide 3. Additional objectives for this unit, Supporting Standards for EHR Application, are to understand other standards that help to support networking and reporting requirements, as well as functionality to optimize the connectivity among heterogeneous systems deployed within a single enterprise. Understand Single Sign-On Standards and the HL7 Clinical Context Object Workgroup (CCOW) standard. Understand Regulatory Standards. And understand issues relating to person identifiers, master patient indices, and record locator services. Slide 4. Clinical Decision Support, or CDS, applies knowledge to data to provide information to the user. With CDS, we apply information technology to address, in a systematic manner, questions and other information needs that arise during patient care and clinical research. The medical literature has advanced at an accelerated pace. Over 1 million articles are introduced each year, and no human can keep up. The scope of knowledge overpowers the human mind, and computer-supported decision support is necessary for safe and quality care. Meaningful use requires the use of decision support. Developers and users of CDS systems seek to improve clinical and public health outcomes. CDS can inform and alter healthcare decisions and standardize decisions and procedures for clinical research. Effective use of CDS, however, depends on the ability to access and understand specifically the data contained in the EHR and required by the CDS algorithm. Slide 5. CDS further provides concise, accurate, and unambiguous factual information, accepted scientific knowledge or consensus expert opinions, and advice containing evidence and recommendations, and addresses information needs at the point and time of decision-making. Accomplishing these goals requires computer-based representations of general medical knowledge, content or domain knowledge, application-specific decision logic, clinical algorithms, and accurate, standardized representations of current patient data and clinical states. Decision support provides knowledge, facts, and advice based on those facts at the point and time of decision-making. The challenge is to represent knowledge in such a way that it can be applied appropriately by a computer using timely patient data. Slide 6. CDS uses knowledge bases derived primarily from the peer-reviewed scientific literature. Carefully derived expert consensus may suffice, and evidence-based knowledge obtained for clinical data with outcomes. Clinical trials produce and prove new knowledge. Data mining, including patient signs and symptoms, clinical data, decisions, treatment, and outcome, is rapidly becoming a major source of knowledge. Slide 7. The most effective application of clinical decision support systems comes from a service-oriented architectural framework in which the CDSS service is encapsulated from the EHR. Triggers associated with specific data elements interact with the CDS service component, passing the required and specified data elements. This process is a pull, where the functionality of CDSS is invoked by the application. The CDSS module does its work, then pushes the response back into the clinical application. The CDS module contains and accesses the appropriate knowledge to carry out the request. CDSS supports both a push and pull framework. Slide 8. Some decision support tools are Knowledge Reference Framework and Knowledge Representation, such as Arden Syntax or Jello, Clinical Guidelines, Guideline Interchange Format, GLIF, and Guideline Elements Model, GEM, Disease Management Protocols, Info Button, and Evidence-Based Care Plans. 2 SDOs have contributed primarily to decision support standards. HL7 has contributed Arden Syntax, Jello, GLIF, and Info Buttons. ASTM has contributed GEM. We will later discuss each of these standards, as well as some approaches to disease management and evidence-based care plans. Slide 9. The name Arden Syntax was adopted from Arden House, located about 90 minutes north of Manhattan in Orange County, New York. Originally purchased by Edward Henry E.H. Harriman in 1885, the estate was given to Columbia University by his son, William Averill Harriman, in 1950, following its use by the Navy in World War II. A group of medical informaticians from several leading universities and hospitals, IBM personnel, and others involved in defining a standard for representing and processing medical conditions and recommendations met there. The Arden Syntax name was chosen in recognition of important milestones achieved at Arden House in the development and refinement of the syntax and its implementation. The work on the Arden Syntax moved into ASTM in 1992 and was transferred in 1999 to HL7, where it became an HL7 standard. Work on that standard continues at HL7. The current version is 2.8, and version 2.9 is in final stages. Arden Syntax arose from the need to make medical knowledge available for decision-making at the point of care, to make the knowledge and logic explicit, to allow sharing within and between institutions, and to standardize the way medical knowledge is integrated into health information systems. Slide 10. Arden is a rules syntax specification that allows rules to be individually published independently of a computer system and subsequently imported into computer systems for healthcare use. Arden implementation guides are published in a modular format by content providers, a guide for each rule. Arden version 2.6 syntax is a formalism of procedural knowledge representation in clinical decision support systems. This lecture presents version 2.6 of the Arden syntax. HL7 is now developing a fuzzy Arden syntax that uses XML and was released as version 2.7. A medical logic module, MLM, is simply a text document identifying appropriate data elements engaged in the logic expressions, and the actions to be taken during a given event. MLMs are called by an event monitor when the condition they are written to help occurs. MLM contains slots that are defined for specific purposes. MLM is a stream of text stored in an ASCII file in statements called slots. Slots are made up of a slot name and slot body. Slots are grouped into 3 categories: maintenance, library, and knowledge. Maintenance identifies the MLM, versions, authors, etc. Library includes purpose, name, and keywords, and the knowledge is expressed via a logic algorithm. Slide 11. This slide illustrates a slot from the maintenance category. It contains title, Contrast CT study in patient with renal failure, semicolon. MLM file name, colon, CT_CONTR.MLM, semicolon. Arden Syntax version, colon, 1.00, semicolon. Institution, colon, Duke Medical Center, semicolon. Author, colon, Dr. John Doe, MD, semicolon. Specialist, colon, Dr. Jane Doe, MD, semicolon. Date, colon, 2010-09-11, semicolon. Validation, colon, testing, semicolon. Note the syntax of the slot. Name tags are terminated by a colon, and contents are terminated by double semicolons. Slide 12. This is an example of the library slot. Again, name tags are terminated by a colon, and contents are terminated by double semicolons. It contains purpose, to alert the healthcare provider of new or worsening serum creatinine level. Explanation. If the creatinine is at or above a threshold 1.35 milligrams per deciliter, then an alert. Priority, optional, not included in this example. Keywords: renal insufficiency, renal failure. Citations: Proceedings of the 15th Annual Symposium on Computer Applications in Medical Care, 1991, November 17th through 20th, Washington, D.C., New York, IEEE Computer Society Press, 1991. Links: URL, NLM webpage, http://www.nlm.nih.gov. Slide 13. The knowledge slot contains type, coded and required. Presently, only data-driven type is defined. This type requires these additional slots to be defined. Data, structured. Priority, coded, optional. Evoke, structured. Logic, structured. Action, structured. And urgency, structured. Action is an action produced when the logic slot concludes true. Slide 14. The data slot identifies what data is involved in the logic and decision-making and must be matched to the terms contained within the application database. The required data elements are identified with a set of curly brackets. This has been a sore point for the Arden Syntax because it requires mapping for a local database and terminology set to a global construct. Mapping terms in this way separates the logic in the medical logic models, MLM, from institution-specific information. It has been referred to as the curly bracket problem. If semantic interoperability existed, then MLMs would be shareable globally. The potential for the number of MLMs would be thousands, if not millions. Note, the curly brackets problem will be solved in version 2.9 by incorporating the health level, HL, and reference information model, RIM, into the standard. Slide 15. The data slot identifies the required data and invokes the extraction of the actual values of the data item from the application database, EHR. The read command is used to obtain a value for the identified data element. A read statement without an operator will contain a list of data elements that obtains a list of all values for that data element from the database. A read statement with an operator returns a single value. Typical operators include first, last, minimum, maximum, count, average, and sum. Can you think of any other operator that you might use? Slide 16. The evoked slot will trigger the logic operation of an MLM. Examples of triggers include the occurrence of an event, timed execution after an event, periodic repetition after an event, and direct call from another MLM. Slide 17. In this example, the data element is creatinine, which could be the value from either data element 32506 or 32752. If the creatinine was measured as a single test, these are the codes for the data element, or could be part of a Chem 20, where the creatinine was part of a battery. The evoke slot also sets the date-time of creatinine storage. The text between the asterisks is a comment. Slide 18. This slide shows 3 other examples of an evoked slot. 1. 3 days after the time the creatinine was taken. 2. Every day for 7 days, starting at the time of the creatinine storage. 3. Every day starting at the time of creatinine storage and going for 3 days. You can see some sophistication in time specifications. Slide 19. The logic slot contains a logic expression and ends with a conclude statement. The logic slot specifies the medical criteria by using a logical algorithm and ends with a conclude statement. The following slides will include some examples. Slide 20. This logic slot shows 3 examples of logic. One type of logic statement is if-then statements. The permissible constructs include if expression, then execute a block of code, if-then-else constructs, and if-else-if, and nested logic sets. Slide 21. Looping statements are permitted. Looping statements are do-while statements and for loops. Slide 22. Call statements permit linking to other MLMs, including passing parameters. Examples of call statements are var1, call my underscore MLM with param1, param2. var1, call my underscore event with param1, param2. var1, call my underscore interface underscore function with param1, param2. Slide 23. This slide includes specific examples of call statements. In a later unit, we will talk about a service-oriented architecture framework approach. This construct supports that concept by providing service-specific functions with a defined call and defined return. Slide 24. Every logic slot must end with a conclude statement. The conclude terminates the rule. In addition, conclude true goes to the action slot for action to take if the logic condition is satisfied. Conclude false terminates the rule and does not go to the action statement. Slide 25. In this example, if the record does not contain a creatinine value, show the alert message, "No recent creatinine available. Consider ordering creatinine before giving IV contrast," and end the logic rule. If there is a value of creatinine and that value is greater than 1.5, then show the alert message, "No recent creatinine available. Consider ordering creatinine before giving IV contrast," and end the logic rule. Else conclude false and end the logic rule. Slide 26. The action slot defines the action to be taken. Examples include write message to screen, store a message in a file, and call another medical logic module. Slide 27. This action example results in the following display. Last creatinine 2.36 on 2010-10-16 T0630. The double filter bars will print the value of the data element after the filter bar. Slide 28. Another action slot example will send an email to ed@duke.edu. The contents of the email will be, patient who may qualify for study registered today, PT number 123456778. ed_email defines the email address of the destination target. Slide 29. The urgency slot defines the importance of the action. The urgency may trigger different paths for the message, that is, a page, a call, or an email. Slide 30. The concept of time is important in decision logic. We need to be able to measure intervals of time between events. Duration can be expressed in years, months, days, hours, minutes, or seconds. The ability to compare times is also important. These comparisons are supported. Time is before time. Time is after time. Time is equal time. Time is within time to time. Time is within duration preceding time. Time is within the past duration. Slide 31. The slide gives some typical operators that may be expressed in the logic statement. They include assignment of a value to a data element, potassium, equal sign, 3.3. Comparisons such as equal, greater than, less than, greater than or equal, less than or equal, not equal. These comparisons are represented by symbols. Logical and, or, not. Mathematical operations, plus, minus, multiply, divide. Grouping, absolute, square root, log, exponent, and various trig functions. Slide 32. This concludes Lecture A of Supporting Standards for EHR Application. In this lecture, we introduced the Arden Syntax, which has been around for a long period of time. The Arden Syntax is easy to use and has considerable power. One of the complaints of Arden Syntax is that it does not handle complex expressions, particularly those involving timing, such as intervals after other events. The Arden Syntax is used by several notable healthcare systems throughout the United States.